Venus is a world of extremes, often called Earth's twin due to its similar size and mass, but it is a twin gone terribly wrong, with a surface hot enough to melt lead and crushing atmospheric pressure. A profile of a hellscape, second rock from the Sun. Venus is the second planet from our star. Earth's twin. It is very similar to Earth in size, mass, and density. It is also a rocky, terrestrial planet, and orbits within the Sun's habitable zone. Backward spin. Venus rotates on its axis very slowly and in the opposite direction of most planets, retrograde rotation. A day on Venus, one rotation, is longer than its year. The hottest planet. Despite being farther from the Sun than Mercury, Venus is hotter due to its runaway greenhouse effect. Key characteristics and AMP. Facts feature description: diameter 12,104 kilometers, 7,521 miles, about 95% the size of Earth's surface. A young, volcanic landscape with vast plains, large volcanic mountains, like Maxwell Montes, and countless volcanoes. Evidence suggests it is still geologically active. Atmosphere extremely dense, 93x the pressure of Earth's. Composed primarily of 96.5% carbon dioxide, CO, with clouds of sulfuric acid. This creates the intense greenhouse effect. Temperature consistently scorching. A constant 465 degrees Celsius, 870 degrees Fahrenheit. Hot enough to melt lead. The temperature is uniform across the entire planet, day and night. Orbit and AMP. Rotation year, orbit, 225 Earth days. Day, rotation, 243 Earth days, and it spins backwards. The runaway greenhouse effect. Why Venus is so hot. This is the defining story of Venus. It's a terrifying cautionary tale of how a climate can spiral out of control. Sun's energy in. Sunlight passes through Venus's thick atmosphere and heats the surface. Heat trapped. The surface tries to re-radiate this heat back out as infrared radiation. No escape. The dense blanket of carbon dioxide, a potent greenhouse gas, traps this infrared radiation, preventing it from escaping into space. Runaway cycle. The planet heats up, releasing more carbon dioxide from rocks, which thickens the atmosphere and traps even more heat, creating a vicious, unstoppable cycle that baked the planet. Key mysteries and AMP discoveries. Our knowledge comes from over 40 spacecraft missions, most notably from the Soviet Venera landers, which took the only photos from the surface, and NASA's Magellan orbiter, which mapped 98% of the surface with radar. Volcanic world. Venus is covered in volcanic features. Magellan's radar maps revealed vast lava plains, thousands of volcanoes, and strange pancake-like domes called pharos. Tesserae. These are highly deformed, mountainous regions that look like crumpled terrain. They might be like Earth's continents and are a prime target for future study. Recent volcanism? Data from ESA's Venus Express and new analysis of Magellan data strongly suggests that volcanic eruptions have occurred within the last few million years, and possibly even today. The surface. The Venera landers survived for just over an hour in the extreme conditions, sending back images of a barren, rocky landscape under an orange sky. Why is Venus important to study? Climate science. Venus is the ultimate example of a runaway greenhouse effect. Studying it is crucial for understanding the limits of climate change and the delicate balance that makes Earth habitable. Planetary evolution. Why did Venus and Earth, so similar at birth, end up so different? Did Venus ever have oceans? Was it once habitable? Studying Venus helps us understand the factors that dictate a planet's fate. Exoplanets. Many planets discovered around other stars are similar in size to Venus. Understanding Venus helps us interpret data from these distant worlds and determine which might be more Earth-like or Venus-like. Future exploration. A new golden age. After decades of neglect, Venus is back in the spotlight with 3 major NASA and ESA missions planned for the 2030s. Da Vinci Plus, NASA. A probe that will descend through the atmosphere, measuring its composition to understand how it formed and evolved. It will also take high-resolution photos of the tesserae terrain during descent. Veritas, NASA. An orbiter that will map the surface with much higher resolution radar and measure the planet's gravitational field to understand its interior structure and geologic history. Envision, ESA. Another advanced orbiter that will perform synergistic radar and spectroscopic mapping to investigate the planet's activity and its relationship with the atmosphere. Summary. Venus in a nutshell. Venus is a cautionary tale of planetary evolution. It is a stunningly beautiful, evening star in our sky that hides a reality of immense pressure, scorching heat, and acidic clouds. It challenges our assumptions about habitability and reminds us that size and location alone are not enough to create an Earth. It is a world that demands exploration, not despite its hellish nature, but because of it.